protect. With the buffercorn's grit, teaching stale protocols how to fucking commit. Decentralize this, she smirks mid-flight as her wings tickle nodes into doing things right. Up to do with for do with for do with do with do with do 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 do. You ordered a moonwalk across gas feed graves. My mainnet's smoother than your mom's VPN saves. Daughter of the Rockies, high-speed high priestess. Scales of justice ballast on a Memphis Express. Next bottleneck, I see mountain crush it. Click, clack, bosom, lace on firewall. Eyes spooked and truce from dress sheets. That's my device. Nullifier sniffing on my clothes too crisp. Mainnet gossips, tastier than breakfast chips. Story, hack, flurry. Mama's making news before the cold reload. Got receipts in my cheeks, encrypted and plumbed. You private DMs, I'm the dumpster dive chump. Eyes everywhere, not just three bird phones. Haunteries whisper, king chomp and blockchain bones. Make it down to voted fuck. Stealth crawl through your junk dead scene. Head it up to the entropy. Mace cracked vaults like who's got the keys? Nullifier's huffing, you're just a rat with firewall splinter to confetti bits. I'm curating leaves at the after party, sipping TLS tears. Call me well connected, I call it.
Guitar slide. Guitar slide.
Coffee for drip and the lab coat on fire. Sticky note, constellation stuck to the ceiling wire. Gas fees are confetti, they rock on PI.
All right. You ready, Taco? All right, Taco, we're counting.
We are. I apologize. Eric, how are you doing today?
I'm doing wonderful. We're at the end of a really great ETH Denver here. I'm sure I sound like I'm in a metal band.
I think I sound like I'm in a metal band because I was smoking cigars all night. For those that don't know, my name is Player One Taco. I am the CDO of the Manifest Network, and I'm here with Eric Bravik. Eric?
Hey, nice to meet everyone.
So today we're talking about the importance of data privacy with AI agents. That's a hard topic, like that is almost extinct because we give out permissions with everything we do. What's sort of the overall thought of that?
Yeah, so if you look back at the arc of history here, it's probably good to start with what the fundamental problem here is. If you look back through human history, it took hundreds of thousands of years to organize basic tool sets for humans. It took tens of thousands of years for them to organize that to a level of standardization that you could get some basic uplift. Took thousands of years to organize into standards so you could get agrarian economies, things like that. Took hundreds of years to organize into factories. Took tens of years to control all of factory output with software, and took now only years for AI to eat almost all of software. For those of you who are in the industry, I'm sure you know we've hit that inflection point of AI and AI agents where you're now getting the vast majority of your ability to produce software through AI-assisted means. So what each one of these epochs shows us from a data perspective is that more and more data is generated in each one of these at a geometrically increasing proportion. And there is a further and further separation at each of those epochs between the concepts of ownership and control. So, there's a big difference between owning your data and controlling your data. And AI agents are going to accelerate this to an extreme degree.
So you talked about an interesting piece there of ownership and control. Right now, a lot of people give up permissions to interact out of ease, connecting apps. And so they're giving up a lot of permissions for their data. What is that big difference between ownership and control?
Yeah, so this is the difference between data ownership and data sovereignty is usually what we say instead of control. Of the two, this is often misunderstood. Of the two of these, sovereignty is far more important than ownership. So we see this mistake in the set of Manifest incubators all the time. We see probably 5 to 10 data privacy startups a week or so coming in to the platform. I would say 80 to 90% of them misunderstand that data ownership is really not the salient topic to solve for. It's really all about control of the data. And let me give you an example of that. So you may feel that you own the data coming off your Oura Ring, for example. Probably you have one, I have one, probably half of the people here have one, right? But ultimately, that data is not in your control. You may feel that because you own it, you should be able to derive some value from it, which is what the premise of most data privacy platforms is ownership equals value, and that value should come back to the user. But there's a fundamental misunderstanding here of the value is created by the control, and the value is created by the product cycle that only the controller can move the data through. So it's really the controller that generates the value. And so the value stream goes to the controller. And that's probably correct in that case.
But there's so many platforms today that say that I get to control and own my data through tokenization, and that AI platforms now allow me to gain value from my data. Is my data individually actually valuable?
So there are some very good platforms in this space. I don't want to neg this space. We should be doing this. And there are some very good examples. One off the top of my head is Vanna. And I think they understand data, and so they're going to be properly successful in that space. Your data individually for most use cases is actually not valuable. So that's one of the common misunderstandings. There's a game theory problem here, which is if I'm a curator of data and I'm building, say, large machine learning models, AI models, or even doing traditional data analysis, if I have a subset of users that want to opt out of that, usually at scale, that's totally not a problem for me. So from a game theory perspective, I'll just take the users that want to opt in 99% of the time. So from a game theory perspective, the users that want to opt out don't matter. They don't have any value to me, so I'm not going to pay them. The second thing is that your data individually, you may view it as valuable, but it's not valuable from an analysis standpoint as an individual under normal circumstances. So I have plenty of data. I do the analysis. And if you're not in the data set, that's fine. So again, I'm not going to pay you. So this is just simply a fundamental value proposition problem. Now, that doesn't necessarily mean when I have, say, an AI model that I don't need my data, right, to put into the model to say where do I fit, right? So if I'm doing like a health model, for example, I need my data to figure out where I fit in there. My data now becomes valuable to me, but it's not necessarily valuable to the provider in aggregate, the controller in aggregate.
So we're seeing a lot of different acronyms getting used about data privacy. FHE, fully homomorphic encryption, TEAS, trusted execution environments. Are they actually actionable things right now in AI?
Well, that's a broader question. So there are actionable things that we can do in AI. Again, I'm very pro having platforms that try to promote data privacy, but the problems of data are significantly complex. So for example, a lot of the data that is important about you is emitted by you but not owned by you. This is metadata, right? So I can tell a lot about what's going on from the metadata that you emit. That's not data that you own, and it's data that someone else controls. So all of these concepts really come down to sovereignty and not ownership, right? So that's why we work in the sovereignty space with our partners, and really talk much more about sovereignty when we're talking about data. Is do you control those emissions, right? Yeah. How much of them do you control? Do you control where they go? Is that even possible, right? Now, keep in mind, we're entering a massive accelerated stage of growth right now. If you know where we are on the curve of AI acceleration, right? Like if you think we're at the inflection point, that was a year ago. That was 18 months ago for most of those things. We're way up on that curve now. So the more data is being generated at a geometric pace than ever before, geometrically accelerating pace. So, and most of this data is not data you could ever claim ownership over, but you might be able to get some control of some of it, right?
So when we're talking about the control, ownership, and sovereignty of data, we have different protocols out there that provide edge compute. People at home can provide compute for inference for AI agents, but Manifest comes at it a little different angle of like enterprise grade data center quality compute, is that setting a precedent for better control and ownership of data?
Well, if done correctly. So this has actually been an issue with most things that we've tried to do in blockchain is if you aren't starting at fundamental layers of hardware, if you aren't starting at L0, you've got a lot of really significant data privacy and sovereignty problems if you're just implementing from the top of the stack down. There's a lot of promising work going on in ZK and other technologies. There's a lot of work going on with various types of trusted computing platforms. A lot of these are about access controls and encryption. That doesn't necessarily directly translate to data privacy in the way that you would think it would, especially with AI agents. So imagine a world where there's 1,000 AI agents running every aspect of your life. You have a super agent, which is running all of those agents. And those agents are collecting and calculating massive amounts of metadata about you. Many times, I actually don't need to know the data that you are attempting to hide from me through encryption and these methods. I know everything I need to know by the metadata that you accrete around you in your data accretion disk, right? If you think kind of a black hole concept, right? Even if I have perfect encryption of my data, all of the products I use, all of the agents I'm going to be using, the agents that are going to be running my life, my finances, controlling all my assets, controlling all of my comms. I'm going to be able to correlate most of the data about you from that. So what really becomes important is sovereignty in this case, that I have control of those AI agents, and I have control of them whether or not information about me in any way leaks, right? Or is calculated by other AI agents from a metadata standpoint. So these AI agents, you got to understand, they're going to be faster at everything, and they're going to swarm anything that they want. So if someone wants to know something about you in the future, or make something up about you in the future that's not true, swarming AI agents are going to be able to do that across the entire spectrum of information production. So it's more about sovereignty over the super agent that runs the agents that run your life, because the information is going to be very difficult to protect. So if you're worried about protecting your data versus sovereignty, worry about sovereignty first, right?
So that's a little bit of a bleaker perspective versus what everyone likes to talk about, where AI is going to make everyone's life better in some way, shape, or form. But then there's really cool projects like Venice or Morpheus that work to give a little bit more ownership and control into people's hands of their data that they're using AI for. Now you're talking about a super agent, or what we've talked, named, personal AI agent in some way, shape, or form. What is something that someone can do today to sort of protect themselves or prepare?
Well, so let's start with, I don't think that's actually a bleak perspective, because again,
honest perspective.
Right, because again, if you're I'm going to combine the two of these two things into one answer. The thing that you can do right now is get really familiar with agent frameworks, get really familiar with running agents that operate on your behalf. If you aren't already doing this, you're already behind the curve, right? So get into AI agents, get on the leading edge of how this is working, right? And get comfortable with AI and AI agents running parts of your life, because this is going to happen whether you want it to or not, right? Make sure those AI agents are sovereign, That is the key. There will be many cases in which you will not be able to control your data, and you will not be able to control the metadata that will reveal your data, whether you encrypt it or hide it or not. That problem is going to get worse. So I'm not here to tell you it's going to get better. It's not. It's going to get worse. But what you can do about it is grab AI agent platforms, you learn to use them, make sure they're sovereign platforms so that you control the AI, and then start getting into the zone of establishing control, right? Forget about ownership, forget about derivative rights, forget about making revenue off of that. You know, not that those aren't noble goals, right? And there's lots of great platforms, again, as I already said, that are trying to do that. But practically speaking, right now, that's not going to help you. That's a long tail thing. What's coming for you really, really fast is AI and AI agents that are going to run everything about your life around you. And that's going to happen whether you like it or not. So you have to just be prepared for that reality. And I don't think that's bleak, because this is also incredibly empowering. If you do this correctly, your health will be better than it's ever been. Your mental status will be better than it's ever been. Your wealth will be better than it's ever been if you do it correctly. So you're empowered. This is an age of empowerment. But if you do not do it correctly, if you ignore it, then putting your data in a data privacy platform by itself, that's not going to do anything, right? And again, not negging those platforms. Love that they exist, partner with many of them. They're great, but it's not going to help as an individual item.
So before we wrap up, we want to just shout out to ETH Denver having us here to talk about this today, sort of covering this hot topic as the first speaker of the day today. Before we wrap up with last thoughts,
Sure.
One of the last things that we ran through too quickly, in my opinion, who are you and what's your history?
Right. So I'm a neuroscientist. I started about 35 years ago in AI after being in neuroscience for a bit. Then spent a lot of my career building sovereign infrastructure systems throughout the world. So when I saw Bitcoin in January 2010, became one of the early Bitcoin miners, I really viewed blockchain and Bitcoin and associated platforms as large-scale behavior modification devices. I never really paid attention to the artificial money part. I know that's what everybody's kind of really into, but I looked them as large-scale behavior modification devices, so protocols. So for me, I've been on a 14-year journey since then of building fundamental blockchain infrastructure as an extension of getting to sovereign AI, right? So for me, my whole life has been AI and neuroscience. So I've always wanted true sovereign AI platforms for people. And here we are at the day that many of us old timers in AI have been waiting for, where we're actually at escape velocity, right, for a lot of this technology. So we're finally here. I'm excited that we're finally here. I'm actually really optimistic for the future. But I'm also a hardcore realist. I've been through all these cycles many, many times. And this does not turn out the way you think it's going to turn out most of the time. So get ready for not knowing how it's going to turn out as well. Rethink what you think time is, rethink what you think acceleration is, rethink what you think data is, rethink what you think ownership and sovereignty are. This is an age to rethink about the fundamentals of how your lives have worked related to data up to this point, because everything is going to change. We're entering a new epoch. And at each one of those epoch changes, all the old rulers disappeared. and a new class emerged, and that's what's happening now.
Awesome, thank you. And for those that don't know, for some reason, my name is Player One Taco, and I talk about what other people do. You can talk to Eric over there if you have any further questions. Thank you, everyone.
We're biddylers, not just dreamers. On-chain truth, no middle schemers. Forking hard and shipping code till sunrise every day. DAOs are voting, vibes are flowing. Buff corns are still a-growing. While the world is breaking down, we're regen in a new way. Some VC said this tech won't last. And the hurt bubble, watch it crash. But we don't need your central banks, 'cause regen biddlers stack in stacks. For we bid let this city on force and chains. We bid let this city with regen brains. We bid let this city on force and chains. No rug pulls, just pure on chain. Whale pools floating, fees are burning. ZK proofs the chains keep turning. Every block we validate is trustless, clean and fair. Open source and gas optimized, code permissionless and fine.
Analyst at Placeholder Ventures, which is a crypto native venture fund based out in New York City. And today I wanted to talk a little bit and provide some clarity on the whole crypto AI vertical and really break it down to its bare bones technical level. There's been a lot of talk about and excitement about crypto and AI and how the two intersect. And I think today I'm going to put a little bit more of a somber tone and break it down to its technicals on where the crypto stack helps AI and where the AI stack helps crypto. So where I want to start is by defining what I believe the AI stack consists of, right? On your bottom, you have your compute, your data layers. Right above that, you have your training layers, which is essentially taking in the raw goods and processing it into something useful. On top of that, you have your dev tools, your inferencing providers, and at the top, you have developers creating applications and agents that leverage these training and inference infrastructures to create something valuable for us everyday users. And I'd like to focus on the bottom two, the compute, data, as well as the training layers. Now, a lot of folks have probably mentioned the fact that we can decentralize some of these training, these compute, these data collection mechanisms, but the question is why? It seems that we're decentralizing for the sake of decentralizing without considering the performance and efficiency trade-offs for doing so. And my thesis here is that centralized providers currently that collect data, that house compute resources, and therefore translate those into training foundation models currently do and will continue to have an advantage as compared to our decentralized counterparts. And the reason for that, just pure economics and scarcity. If we think about it today, demand for top-line hardware, data, and compute resources will always outpace supply. And since those are the primary ingredients in creating training resources, what we'll see is that centralized providers will continue to outcompete and outperform decentralized counterparts, at least for the foreseeable future. What this lends itself to is an observation that scarcity for top-line hardware, data, and capital equates to centralization within our most performant foundation models. And this is going to continue happening. You have your NVIDIA chips now in their current V1. You have V2, V3, V100 versions of these coming out. And the top-line providers will always have a higher demand as compared to supply for some of these compute resources, thereby leading to centralization at the most fundamental training, compute, and data locations. Now, this kind of puts a bleak outlook for the future of decentralized compute and training layers. But I'm here to tell you that it's not all bad. What we'll find is that when you start generating these different versions of top-line hardware, it's not like the older hardware is now suddenly moot or useless, right? The top-line hardware is only supporting the most performant top-line models. But what happens to the older hardware that works perfectly fine, but just for older use cases? Well, I believe that it finds allocative efficiency. So as you can see here, we see old hardware that's supporting mid-tier models as compared to and then services decentralized compute networks, therefore servicing on-prem and edge models, personal data sets, and maybe smaller tasks. Now on the other side, what we see is top-line models. These top-line models, sorry, let me make sure I'm presenting this properly. There we go. So these top-line models, therefore, will service more complex models. Therefore, will be centralized and might be centrally hosted complex performant tasks. Now, an easy way to walk y'all through this is, let's say I'm a personal user, and I'm using my iPhone to execute a simple task. Maybe I want to book an airline. Do I really need NVIDIA's H100 chip for me to execute a task on Expedia? Probably not. And so what I'm probably doing is, okay, we have old hardware on my edge device, serviced from mid-tier models that can fulfill said task and are good enough to do so. They're able to run on decentralized compute and training networks because it's cheaper, more affordable, and more flexible than its centralized counterparts, and it can exist on our edge and can service our personal data. On the other hand, let's say I'm executing an incredibly complex task. Maybe in this case, my iPhone that's running some edge model can't service said task. What we can imagine then is my iPhone or my edge device obfuscates my personal data, my personal identity, and my personal request, sends it to a complex model, maybe hosted in a centralized way, because that's what their advantage is. It's run on a centralized training model, and therefore can perform more complex performant tasks. Now, moving on from here, what we see is this thesis that maybe the factors that we're competing on for decentralized training and decentralized compute are incorrect. If you think about what people are marketing themselves as today, they're saying, we're going to become the next OpenAI. We're going to essentially replace what folks are building on, the OpenAIs, the Microsofts, the Googles of the world. Maybe the factors that we want to compete on instead is, look, those guys have the most performant hardware. They have the most performant data. That's great. Good for them, and that's where they can operate. But what we on the decentralized area really compete on is verifiability, flexibility, and censorship resistance, and to a certain extent, affordability. And I think if we continue harping down on those areas, that's where we'll see our advantages. Now, moving on, we can see that this lends itself to an eventual transition in the training model. Currently, our decentralized training models are censorship resistant, and that's great for them. On the centralized part, we have potentially biased and centrally run models. And we can see that that's a relative market share split. Most of the decentralized models are run by hobbyists, independent researchers, and startups, whereas most of us use the OpenAIs of the world. What we could see, though, is a transition to this future, where decentralized models end up capturing most of the mindshare for our individual users. And then centralized models are potentially biased and centrally run, but are reserved for top-line performant and complex tasks. And so it doesn't have to be a centralized versus decentralized. It could be that they exist together. Now we move on to inferencing. So let's move one layer above on the stack. Right now, it's the same thing with inferencing models that run on top of decentralized or centralized training models. They offer zero downtime, public evaluation and reputation scores, and a set of diverse outputs. On the centralized side, though, there's bias, vendor lock-in, a lack of verifiability. We're placing trust in these actors because we have no other option. But again, if we focus on competing about censorship resistance, we focus on competing on the factor of affordability and flexibility, we can exist in this future where most user requests for inferencing are completed by decentralized inferencing providers, and only the most complex requests are completed by your centralized counterparts. Again, this whole thesis of coexisting rather than one against the other. Now, what this lends me to is a thesis that I express in a blog post, which y'all can read online as well, that decentralized compute networks and inferencing networks present a unique value proposition around more personalized, affordable, openly competitive, and censorship-resistant AI. And I think these are the factors that we have to compete against to eventually gain market share against our centralized counterparts, as compared to butting heads with them, rather treating them as equals and therefore coexisting with them for certain tasks. Now, before I end my speech, I would like to say that there's a lot of innovation that I've seen at this ETH Denver, specifically on the agentic app layer. And a little bit of a thesis there is, you could imagine, as I said before, you operating with your iPhone or another edge device and fulfilling requests in natural language, and therefore not having to deal with the complexity of finding resources yourself, but rather just speaking it into existence. Now, how does that coordination at that agentic layer happen? I think that's a really cool question to answer. Anything around agent discovery, agentic coordination, and communication. So if y'all are building in that space, researching in that space, feel free to get in touch. That's my Twitter over there, and more than happy to talk about it afterwards as well. Appreciate y'all's time. Appreciate ETH Denver for having me out here. Thanks again.
Where we pity let the city on sports and chains. We pity let the city with reach and brains. We pity let the city on sports and chains. No rug pulls, just pure on chain. Whale pools floating, fees are burning. ZK proofs the chains keep turning. Every block we validate is trustless, clean and fair. Open source and gas optimized, code permissionless and finalized. Fork marmots on the scene, you know we're gonna bid a little it there. Some tread fibro just rolled his eyes. Where's the yield? Where's my supply? But we don't need your banker games. We just launch and stake on chain. Go, we pity let the city on sports and chains. We pity let the city with reach and brains. We pity let the city on sports and chains. No rug pulls, just pure on chain.
Ladies and gentlemen, hello. Today marks a turning point. It's a moment of change, the moment of renewal. It's Metis Regenesis. Today, Metis is reawakening its core purpose and declaring to the world that we are absolutely refuse to be bound by the limitations that held our ecosystem back for way too long. Today, we are stepping forward and declaring that we're starting to build the next generation of decentralized intelligence. Before we get there, very briefly, my name is Natalia Amelin. I am a decentralization coordinator at Metis Foundation and co-founder of CryptoChecks. And my role at at Metis Foundation is to focus on decentralization, to make sure that it's not just some idea, but rather we live it every day and we focus on it and ensure that it drives a meaningful progress. So first, let me tell you what Regenesis is. Regenesis is not just any technical upgrade. It's rebirth of Metis in an era of AI. Our mission is not just revitalize Ethereum ecosystem. Our mission is to power Web3 with the foundation it needs to be successful in the age of AI. So how do we do it? Well, the answer is simple. We are on the brink of technological revolution. AI has been taking the world by storm, and we all have been observing it. It feels like we just walk in a different world. Every morning we wake up and there is new innovations coming along. But there is one big problem. AI is centralized. It is all held and controlled by a handful of tech giants, large corporations. They own the data, they own the models, they have the power, they have us. Web3 should be an answer to that, because our whole thesis in the Ethereum ecosystem is decentralization. But the problem is we are not ready. We are not fast enough, we are not smart enough, we are not agile enough to handle the demands that AI places on us. And that is exactly why the Regenesis is happening now. Ethereum has been a backbone of Web3 for a while, but it cannot handle in the present state the demands of the future. And that's why Metis is stepping forward as Ethereum L2 to ensure that we're ready, that we scaled, and that we have good tools to be successful. Web3 has been stuck in this constant debate. What should we prioritize? Should we prioritize decentralization and innovation? Or should we go and optimize for speed and for user interfaces? And projects have to choose. There are trade-offs to be made. But Metis refuses to believe that we need to be bound by these limitations. We strongly believe that the infrastructure can be both decentralized and fast, both innovative and scalable, and secure and user-friendly. And when we look at what AI needs, AI ecosystem needs not just another chain. It needs a space where it can build, where it can thrive, where it can come up with new cases, bring new users, develop new paradigms, and push the Web3 to the areas and focuses that it's never been before. It needs to bring, it may bring new users, drive real adoption, It can transform how we handle the data and how transactions are executed, how we interact with the smart contracts. And, but AI space today is defined by closed-sourced models, by black box algorithms, and by centralized control. And this has to change. By rethinking AI architecture, by completely rethinking how we think about the blockchain, Metis is moving forward from this outdated argument into the world where Web3 can actually become a decentralized, trustless foundation, the layer for AI to thrive. You probably want to know how. We believe that the path is through two-pronged approach. A, focus on a foundation by providing the infrastructure that AI developers need, and B, by solving hardest AI problems. AI developers don't need just another chain. They need a chain that works for AI. And that's why we are providing a dual chain collaboration mechanism with the Andromeda chain upgrade and by building a new instant layer 2, we are unlocking the real-time AI execution. This way, Metis is bridging AI and Web3 in a way that has never been done before, where AI models can exist on-chain, interact with smart contracts, and process data in real time. Let me introduce you to our instant layer 2 Metis Hyperion. It is AI-aligned, human-defined. Some of its characteristics are it has instant finality. AI cannot wait for the block confirmation, so we make them instant. It boasts parallel execution, so workloads can be handled dynamically and thus optimizing for AI computations. It has a network of decentralized sequencers to support decentralization thesis and to ensure that the calculations and that workload is also distributed dynamically. And it has Ethereum settlement layer and chain interoperability. Hyperion is built on Metis SDK, all open source modular framework designed for developers to work at ease. At the core of Metis Genesis is our virtual machine, Metis VM. It's EVM compatible, but it doesn't have its limitations. It supports the parallel execution, which is so important to make sure that we can handle complex problems that AI presents. And it is optimized for AI. AI also needs to be able to handle large volumes of data. And that's why we believe that we need to build our own Metis data layer. The first AI-native decentralized data layer, Metis DB. With its low latency, we can thrive for real-time execution. Its concurrent read-write operations eliminate the conflicts and bottlenecks. And it has a cryptographic security that ensures that AI-generated outputs are verifiable and tamper-proof. Metis database layer allows AI models to train, update, and execute without friction. Over the next months, we will be methodically rolling out the various components of this new real-time L2. One of the biggest challenges today that presented by AI is not just scale, it is data misalignment. AI today is increasingly considered black box, and it's impossible to interpret. Adding the blockchain, adding an issue of lack of high-quality data for its training, And we have a perfect storm where AI systems are becoming increasingly complex, hard to understand, and powerful. Anticipating and aligning to human values becomes very difficult. For AI to truly integrate with Web3, we need a transparent, verifiable, decentralized data governance. AI models depend on supervisory signals, but these signals can be flawed. And that results in AI-generated misinformation, in models that are heavily centralized and fail to align with human values, and a system that is controlled by opaque entities with questionable data privacy. Without open, decentralized, and verifiable data, AI will remain a black box. And here comes Metis LazyEye to address the issue of AI data alignment and challenge through an architecture built around verifiable computing, composable AI environments, and assetization framework. At the core of it, there are three mechanisms. We update DAOs to iDAOs, which allow individuals to contribute data, validate the models, and manage AI applications, and maintain transparent, accountable governance process. We have the new token standard, data anchoring token, specifically designed for representation of AI assets. This approach not only mitigates the risk of data corruption and manipulation, but also creates opportunities where individuals can directly capture the value that they generate from their contributions. And it's based on verifiable computing, which ensures that AI model outputs and data are cryptographically verifiable and trustless. The first step for LazyEye and Metis is Alice. It is blockchain native, customizable agent framework. It is designed to execute tasks, to automate your workflows, to ensure the security of the Web3 native environment. It is optimized for the real-time AI execution and supports multiple languages. Its low-code developer tools make deployment very easy. Developers out here, please do take notice. This is the final piece in the puzzle to make the Web3 great again. Please save it, take a picture. You can learn more about what Metis is working on, what LazyEye is working on, and about Alice. Also, follow us on the Twitter. Regenerates, are you ready for the new era of Web3 and AI?
Your nemesis like runs dial up found. Old to speak, young as each block mine down. Professor Waze got the future on spin. Urging notes dancing where the bottlenecks been. Professor Waze got the future on spin. Plugging tomorrow with yesterday's ram stains. Throwing me mad, but mad's just a beta test for Boodle. Oh, Pete Jobs, right? Oh, Pete Jobs, right? Oh, Pete Jobs, right? Oh, Pete Jobs, right?
And today I'm going to be talking about Shade agents, the first truly autonomous, non-custodial multi-chain agents. You can find out more about Shade agents at near.ai/shade. So if we look at the state of agents, basically in the Web 2 space, we obviously have seen some really interesting things happen recently with OpenAI's Operator. And there's a lot of hype just in general around agents in the Web 2 space that's pretty frothy and crazy in traditional tech world, as well as in Web 3. So we've seen a lot of agentic frameworks that have launched in crypto. And we've also seen some really amazing agents for things like Signal and also just entertainment value and digital twinning. But we did see some pain points with how these agents are launched, and 3 specific ones were decentralized key management. So basically a lot of agents are run in trusted execution environments today, but the keys are not really sort of well managed. They're either kind of held by the developers, and in the trusted execution environment, if it goes offline, maybe the key's lost, or it's just a kind of an insecure way to manage keys inside a T itself. And then also there's the problem with full code verifiability. So how do we know that the agent that's running this code is actually running the code that it says it is? Things like basically upgrade processes and stuff for the agent code. It's all kind of a little bit loose these days. Like, we're not really sure what these agents are running, and there's no real kind of verifiability there. And also, we feel that these agents are lacking smart contract guardrails. So basically that final step of sort of protection of, for example, like user deposits before some action can sort of be taken with them. So we set out with a mission to basically enable the building of truly autonomous agents for everyone. So we built the Shade Agent stack. And basically, if we look at the top layer of the stack here, we have worker agent code. So this is any arbitrary code running inside a trusted execution environment. So this worker agent code can contact Web 2 APIs, storage, compute, and then it can bring that back into the trusted execution environment where it's running verifiable code. It can also run LLMs, or it could talk to LLMs outside of the trusted execution environment. It can really do kind of like anything that you can think of. Where this is interesting, though, is that the worker agent is tightly coupled with the smart contract layer that you see at the bottom in the Shade Agent stack. And the worker agent basically gets its remote attestation from the trusted execution environment, which basically tells the smart contract that it's running inside a T. But it also gets the code hash of this arbitrary code that it's running. So the developer says, hey, I've got a worker agent here with this particular code, and it runs with this code hash. And then the worker agent registers in the smart contract one time and basically says, I'm running inside a T. Smart contract checks that, verifies it, and then also registered with that particular code hash. Any subsequent calls from the worker agent to the smart contract are basically already pre-verified, and we can do method access control in the smart contracts based on that code hash. So this is a very interesting kind of part of the Shade Agent stack, and it opens up a whole new design space. So as I mentioned before, in current T implementations, we've got the keys maybe managed inside the T. If the T goes offline, or if there's some sort of new code pushed or whatever, this is a really insecure process. And basically we could lose the connection to the protocol and to the user's funds, and all sorts of things could go wrong. So what we did was we basically made it so that worker agents don't need to manage keys, and basically the worker agent could just go offline, and anyone could boot up a new instance of the worker agent, provided that they're running the exact same code, and still get access to the smart contract and the various methods that manage those keys. So that's a key differentiator there, pun intended. So this is the registration process for the worker agent code on the left and the smart contract on the right, and how you would kind of go all the way through to basically making on-chain transactions. It's a little bit much to go over, but you can check this out at near.ai/shade. So we've deployed these Shade agents already live on Fala Cloud. So we've used them as kind of like a partner for our first Shade agent template. And all you really need to do is just deploy some Docker YAML, and basically you're up and you're going with your first Shade agent. In the worker agent code, so in this like arbitrary kind of, this is JavaScript, but we also have one that's coming out for the shade agent template in Python as well. There's really just a small amount of code for that agent to basically create their own account that can call the smart contract. And we create this account with the Tease hardware entropy. And as I mentioned before, the big kind of differentiator here is that we grab the code hash from the Tease hardware and we basically pass that through to the smart contract register method. Now this creates a really tight coupling between the code that the worker agent's running and the smart contract. So we can do interesting things like method access control. So here we have a bunch of worker agent instances. We can have many worker agents that all have access to a particular method in a smart contract by virtue of them running that specific code that we want them to run. We can also have different worker agents operating on different pieces of a protocol. So we can have worker agent A and worker agent B operating on different parts of a smart contract, which is really cool. We can do this like method access control. So what can you build with shade agents? Well, as we mentioned, it's the first truly autonomous agents. And in the meme token space, I know it's like super hype and frothy and stuff. I like to think of it like we see a lot of agents that are launching with a token. But what does that mean? You got some agent and then you got a token. But where's like the real relationship between them? Like where's the tight coupling between that token's value, supply, or how the token's being managed, and like basically how the ecosystem is being managed around the token? How is that actually connected to the agent? So I like to think of shade agents as the first way that you can actually launch an agent where the agent is the token. So the agent code that's running inside the trusted execution environment, talking to LLMs and maybe doing stuff out on X and stuff like that, and posting, that agent is actually fully tightly connected to the token. And I'll show you an example of that in just a sec. Truly autonomous agents can also deposit and withdraw on any chain by virtue of using Near's chain signatures. So we can do things across any chain. I'll also show you an example of that in a sec. And we can also handle sensitive user data. Because we're working inside Tease, which is a confidential computing environment, we can do things like Web2 payments. As far as DeFi infrastructure is concerned, for things like oracles, we could do things like remove humans in the loop for upgrade processes and conflict resolution. For web markets, I mentioned a T can access any Web2 APIs, so we can really just kind of create markets for anything. And the last concept, I like to think of like it's like the hottest wallet. So basically, because we're inside a T that can talk to Web2 APIs for like auth and other things, we can really create these like chain signature wallets that can access deposits and stuff on any chain with Near chain signatures, but we can tightly couple that with like an X.com authentication as well. So we can basically have users just log in with X and go directly to this hot wallet. So as an example agent, we used our Shade Agent template, and just in a couple of days, we launched this Shade Agent 007. And I'll tell you what it does in a sec. It's just for fun. So we basically launched this agent that will basically read tweets on X, and it'll basically look for terms matching shade agents or AI slop. And if the sentiment is positive, it'll reward you with base tokens on Hyperliquid. Or if the sentiment is negative, it'll reward you with shade tokens. And this is live on Near mainnet and Hyperliquid mainnet. And we just slapped it together in a couple of days. So how this works is basically the worker agent code goes out and kind of reads the tweet. It analyzes it for the sentiment, decides which tokens it's going to give the user. And then it creates an EVM transaction. And then because the worker agent is running that particular code hash, it's registered in the smart contract. And it will basically go and ask for a signature to broadcast on the Hyperliquid mainnet from the smart contract. And because it runs that code hash, it will be given the signature, and then that transaction can be broadcast. So yeah, this is running today. It's pretty exciting stuff. And yeah, just kind of check out shade agents in general. And again, I just want to hammer home this point of method access control. this is really like the tight coupling between worker agent code, like what is an agent actually doing? What is the brain of an agent actually doing? And like how is it kind of like behaving and responding to things? And the actual on-chain transactions or like parts of the smart contract protocol. So thanks for checking out Shade Agents. And once again, you can find out more at near.ai/shade.
Whale pools floating, fees are burning. ZK proofs the chains keep turning. Every block we validate is trustless, clean and fair. Open source and gas optimized, code permissionless and finalized. Fork marmots on the scene, you know we're gonna fiddle it there. Some tread fibro just rolled his eyes. Where's the yield? Where's my supply? But we don't need your banker games. We just launch and stake on chain. Go, we pay let the city on sports and chains. We pay let the city with regen brains. We pay let the city on sports and chains. No rug pulls, just pure on chain. If you faded, just stay seated. The Etherverse will leave you heated. We don't need your legacy, cause regen memes are pro upgrade. Big led the city on sports and chains. We big led the city with regen brains. We big led the city on sports and chains. Rolling up and slapping chains. She's a Colorado Comet in code forged steel. Wings snipping latency like scissors through gel. 9 centuries young with a lance that's if your chain's choking ether night.
Sorry, it's not presenting the slide. Oh, it's coming. Okay. Cool. We are ready to go. Hi. Good morning, everyone. I'm Isabella. Going okay? Okay. Some chit chat. I'm Isabella. I'm from Bay Area. Anyone from California? Yes. So. And I'm from DAppOS. DAppOS is an intent execution network, but today this talk is mainly more like a inspiring session. That I'm not going to talk about DAppOS or any particular projects or promote any specific things. But I'd like to bring you all to a discussion where the AI, Web3, intent, and how they can interact with each other in the new era. Okay. Thank God I saved the PDF so I can use this. So the convergence of AI and Web3, why this comes to our mind? I think a very interesting phenomenon I've seen in Bay Area is that every people in Bay Area is talking about AI right now. Like all the big companies or startups, they're all doing AI innovations, applications, infrastructure, everything. But today, this talk will mainly touch base on the application layer. Like, I'm not going to talk about GPU or computational resources, those sort of things, because I think application layer is more like it's more accessible and it's more easier to understand for most people here. And before we go into that, I want to ask, like, how many of the audience here like write codes, Python, C++? Wow. Almost 50%, I see. But do you know in this world, only 10% of the people knows how to program. Like 90% of the people don't know how to write codes. And also, I want to know how many of you have interacted with large language models at least once in the past 3 days? Oh, almost everyone. Cool. ChatGPT? I would guess so. So I think this is definitely a very hot topic right now in AI with the advanced large language models and all the capabilities. And we cannot help but to think how we can bring this power to Web3 and how can we utilize this strength to strengthen our Web3 community and industry. So that makes me think about what challenges that we currently have in Web3. So for me, I have like 10 years of background in AI. Before joining crypto, I had an internship at Microsoft Research Asia where I did question answering system. I also did some recommendation systems. Like back in the old days when we used deep learning, like not large language modeling. And now with the Web3, when I first entered Web3, I noticed that it's really, really hard to use. Like, it's powerful, but it's also very complex, and it's very counterintuitive for a lot of people, like including me back at that time. I spent like 1 hour setting up my first wallet and had to remember, write down, not screenshotting the private keys. And also had to understand a lot of concepts such as gas fees, bridgings, and all those sorts of very hard stuff to understand. And then with the current AI is definitely revolutionizing, I think, especially in this intent-based interactions. The biggest value it could bring is that it could remove the friction in execution. So our vision, or my personal vision, is that I want to have a Web3 world where the intent is seamlessly understood, optimized, and executed by AI agents. So before that, let's have a relatively clear definition on what is the intent here. Understanding intent in Web3 means that the intent we are talking about today, it's something that is concrete. Like, I want to get rich. That is not my intent, but that's my life goal. But intent is like, I want to do something that can be verified successfully or in failure, right? The intent has to be verifiable. So that's the main difference between intent and anything else. And the current model is that users have to be very, very specific, like with all the details and explicitly define an execution, just like the example here. But in the intent-based model, I want this to be rephrased to, I need 2,000 USDC and at a best rate within 5 minutes. And however, today, there is a lot of limitations that prevent us to fulfill our intent. The complex UX, where you have to understand the gas fees, all these things I mentioned earlier, and also the execution friction that you sometimes have to manually do the wallet interactions by all yourself. And also you have to manually search for the best timing. And there's also a lack of personalizations. For example, every user follows the exact same rigid execution path. And all of these adding together create a lot of barriers. Like, I don't know how many transactions do you do by manually per day, but how many TikToks videos or short videos that you swipe to see every day? See, that's the difference, because the friction is so high that prevents you to use it and go deep with it. So how AI can be helpful here? I see AI as a missing piece in Web3 intent. Is that AI can help with, at least first, it is able to do the NLP translation, like natural language processing, where users, they can describe their goals in very high, describe their intents in very high level plain English or any other languages, of course. And AI can translate them into a smart contract interactions or a sequence of interactions that needs to be taken. And the second is the reinforcement learning. So the easiest way to understand reinforcement learning is you train your pet, train your cat or train your dog. When it does right, you give it a reward. When it does wrong, you don't give it a reward, or you have some little punishment for them. So over time, it will learn how to behave as intended. And with this RL, like reinforcement learning, AI can optimize the routes, slippage, gas fees, and also timing for the best execution, using my previous example. And the third one is the risk management. So AI has been adopted in a lot of fintech areas to detect abnormality, right? Like abnormal transactions, abnormal cases. And this can be definitely adopted in the Web3 world as well. Like it can detect market trends, rug pulls, and map attacks in real time. And that's the most importantly, that you have to do this in real time, because in Web3, we all know that speed and fees are the like the fundamental elements that we develop things here. But AI, sometimes it can be slow and can be expensive to use. So here I come up with some use cases, but definitely not limited to this. And I'm happy to discuss this after this talk. So the first is the DeFi trading and assets management. For example, here AI can enable a trustless and AI-driven smart contract automation, where users can specify their desired outcomes, such as the one I said, like maximize my yield with minimal risk. And AI can dynamically rebalance the portfolio across, for example, off, compound, little. And AI can predict the slippage and math risks, ensuring optimal trade execution. And the second is an AI-powered DAOs and governance. I know DAOs are so nobody talking about right now, but I still feel this is so powerful in governing or managing a community, where you can use AI to summarize the governance proposals and recommend optimal voting strategies based on your past behaviors or your history data. And before you make any decisions, the AI can simulate the outcomes of all your potential decisions and recommends the best one for this community, right? And the third is a personalized AI wallet. I think this is relatively easier to understand. Like users can interact with their AI wallet assistant and get things done. Like they can set their financial and privacy preferences, and this AI wallet assistant can automatically help them to suggest and to execute transactions. And the last one is NFT and metaverse economy. I think, so maybe here I'm more talking about the Gen AI, like generative AI, where you can use AI to curate the digital assets based on users' preferences and buying history. So all of this can be, I can see the potential of using AI to be applied on all of these use cases. And there are definitely some challenges that come in with the AI and Web3 when they combines together. One is the security risk. Like security risk is so important. Like probably a lot of you have heard about the accident happened just a few days ago with Bybit and the Safe, right? So security is always the top one thing that we need to monitor. So we have to ensure that AI doesn't introduce vulnerabilities in smart contracts. For example, I remember previously there was a game that you can send any instructions to an AI, and your goal is to make it transfer money to you. So that was a very interesting challenge, and that actually shows that AI is not like it's not perfect. Like there is ways to hack that, but just like all the other technologies, like none of those are perfect. But we have to be aware of the risks and provide relatively like management on the risks. And there's also decentralization concerns. I feel like OpenAI is not open, right? A lot of models are not open. But DeepSeek is open. But just to say, like, I feel decentralization is also the core spirit of Web3, and I hope the AI we use here is decentralized too. And also there's bias and fairness issues. This is a very like inherited in the AI technology because AI models behaves based on the data you give it. Garbage in, garbage out. Biased data in, biased outcome like you will get. So this is also very important to keep in mind. So the future I see, I feel like AI and Web3 definitely can enable a new digital economy, and this with the democratized access, trustless execution, and the intent-based interactions. But also I want to talk about more on the AI limitations in Web3. I was sitting down there and listening to the previous speakers talking about the AI project, AI Web3 project. I'm very excited, but I also want to just bring this to our attention that AIs definitely have many limitations. For example, AI still struggles with interpreting nuanced user goals. For example, if the intent is that I want to swap ETH for stablecoins at the best rate, but how to interpret the best rate, right? This is very ambiguous, and the LLM is still, they sometimes hallucinate as well. And you have to make sure that it follows your instructions, and that is also a very hard technical tackle to deal with. There are some current solutions. For example, you can do interactive prompting, or ask it to reason why it takes the steps. And also, you can predefine some intent frameworks, like adding all this together to make sure the AI interprets your intent precisely. And also, there is the adversarial environments that it cannot perfectly anticipate market shifts or detect all the attack vectors. There's always misses. So that means we cannot 100%, it's not 100% guaranteed to be safe or to be, to be protected. And there's also privacy concerns. A lot of users may not want financial intents publicly visible on-chain, and as well as the centralization issues, as I mentioned before. But eventually, I still see the road ahead. All these limitations are more like reminders or signals for us to push the boundaries forward. And where the limitations are, their chances are, and their potentials are. And I see the road ahead is decentralized AI, and with some technologies such as zero-knowledge proof, and also with the on-chain memory. So that's pretty much the talk. I'll be around for some time and happy to discuss after this. Thank you for your attention.
All right.
A singularity jukebox. How you stay charged? Espresso straight through my cortex. Who's your nemesis? Light runs down a found. Age. Old to speak, young as each block mine down. Professor Way's got the future on spin. Urging notes, dancing where the bottlenecks been. Professor Way's got the future on spin. Plugging tomorrow with yesterday's ram stains. Throwing me mad, but mad's just a beta test for Boodle. Some TradFi bro just rolled his eyes. Where's the yield? Where's my supply? But we don't need your banker games. We just launch and stake on chain. Go, we pay let the city on sports and chains. We pay let the city with regen brains. We pay let the city on sports and chains. No rug pulls, just pure on chain. If you fade it, just stay seated. The Etherverse will leave you heated. We don't need your legacy, cause regen memes are proof of brain. Big led the city on sports and chains. We big led the city with regen brains. We big led the city on sports and chains. Rolling up and slapping chains. She's a Colorado Comet in Code Forge steel. Wings snipping latency like scissors through gel. 9 centuries young with a lance that's if your chain's choking Ethernight whiz. Found her at a bullet hook sucking down APIs. Armor clinking with layer 2 lullabies. Scalability scripture, she winks at the moon while Lagrange drools over slow motion duel. Her shield's a disco wall, fracturing legs, grass, shooby-doo-bop crack. Ooh, that lance a lightning fork, splitting bottlenecks backs. Alliance architect with a Bufficorn's grit, teaching stale protocols how to fucking commit. Decentralize this, she smirks mid-flight as her wings tickle nodes into doing things right. Da-da-da-da. Alliance architect with a Bufficorn's grit, teaching stale protocols how to fucking commit. Decentralize this, she smirks mid-flight as her wings tickle nodes into doing things right. Up to do with for do with for do it do with do it do 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 you ordered a moonwalk across gas feed graves. My mainnet's smoother than your mom's VPN saves. Daughter of the Rockies, high speed, high priestess. Scales of justice ballast on a Memphis Express. Next bottleneck, I see mountain crush it. Click, clack, bosom, lace on firewall. I scooped and truce from dress sheets. That's my device. Nullify a sniff and bond my corpse to crisp. Mainnet gossips, tastier than breakfast chips. Story, hack, flurry. Mama's making news before the cold reload. Got receipts in my cheeks, encrypted and plumbed. Your private DMs, I'm the dumpster dive chump. Eyes everywhere, not just 3 burner phones. Haunteries whisper, king chomp and blockchain bones. Make it down to my voted fuck. tearless tears. Call me well connected, I call it. Coffee for drip and a lab coat on fire. Sticky note constellation stuck to the ceiling wire. Gas fees are confetti. They rock on PI. Get homemade in 7 for Shaboom goes the efficiency pulse. The lag runs lagging in his latency sub. Professor Wade's got the future on spinball. Energy notes dancing where the bottleneck's been. Professor Wade's got the future on spinball. Plugging tomorrow with yesterday's RAM stains. Velcro boots clicking through blockchain debris. Crypto notes flutter like drunk bumblebees. On bumblebee, optimize the board fins. They cackle and shout. Self-sustaining hubs flicker in the blackouts out. Professor Wade's got the future on spinball. Energy notes dancing where the bottleneck's been. Professor Wade's got the future on spinball. Plugging tomorrow with yesterday's RAM stains. Chaos is not compeller, or it's just a bug I forgot to unfurl. Mainnet shivers as their wild hair glows. Rumored AI, nah, just 3 Red Bulls in a row. What you building, prop? A singularity jukebox. How you stay charged? Espresso straight through my cortex. Who's your nemesis? Lag runs dial-up found. Age, old as speak, young as each block mine down. Professor Wade's got the future on spinball. Energy notes dancing where the bottleneck's been. Professor Wade's got the future on spinball. Plugging tomorrow with yesterday's RAM stains. Throwing me mad, but mad's just a beta test. A bullet or an OP just got just dreamers, on-chain truth, no middle schemers, forking hard and shipping code till sunrise every day. DAOs are voting, vibes are flowing, buff corns are still a-growing. While the world is breaking down, we're regen in a new way. Some VC said this tech won't last, and the hurt bubble, watch it crash. But we don't need your central banks, 'cause regen biddlers stack in stacks. For we pity let this city on sports and chains. We pity let this city with regen brains. We pity let this city on sports and chains. No rug pulls, just pure on chain. Whale pools floating, fees are burning. ZK proofs the chains keep turning. Every block we validate is trustless, clean and fair. Open source and gas optimized, code permissionless and finalized. Fork marmots on the scene, you know we're gonna bid a little it there. Some tread fibro just rolled his eyes. Where's the yield? Where's my supply? But we don't need your banker games. She's a Colorado Comet in code forged steel, wings snipping latency like scissors through gel. 9 centuries young with a lance that's, if you chains choking Ethernight whiz. Found her at a bullet hook sucking down APIs, armor clinking with layer 2 lullabies. Scalability scripture, she winks at the moon while Lagron drools over slow motion doom. Her shield's a disco wall, fracturing legs.
All right. We are coming back from break. Next up, we'll have Brian Crane from Chorus One. He'll be speaking on the topic of scaling Ethereum, the innovations unlocking staking opportunity. Please give a warm welcome to Brian Crane.
Hey, thanks so much. Thanks everyone for coming. So I'm excited today to talk a little bit about Ethereum staking and some of the key innovations or trends and that are affecting Ethereum staking and also the kind of Ethereum staking yield. So briefly about myself, I've been in crypto for a long time. I've been involved in proof of stake for a long time. So in 2017, I was CEO of Tendermint. The company started Cosmos ecosystem. So I've been involved in there since the beginning, and then started Chorus One as one of the first staking companies about 7 years ago. So just briefly about Chorus One. So again, we've been running for around 7 years. We support around 65 different networks, and we work with individual delegators, a lot of VC funds, custodians, wallets, exchanges, all kinds of different parties to help them stake their assets and earn yield on it. So you can see some of our partners here. Now today I want to touch on 3 topics, and I hope I get through all of them. But first of all, pre-confirmations. So this has been one of the most hot areas of innovation and activity in the Ethereum space. So I'm going to talk a little bit about that. We're going to talk about restaking, and then finally touch on MEV and timing games. So pre-confirmations. So basically, what's a pre-confirmation? So one of the challenges in Ethereum is that you make a transaction, it goes into the mempool, and then you wait, and then at some point it's like confirmed it's in the block. So that delay between I make the transaction and it's actually in the block is pretty long. And so one of the ideas that has been explored in Ethereum is whether you can give a guarantee that the transaction is going to be included in a future block, like immediately. And so that has a lot of potential upsides. Of course, to be able to do that, you need to have the different actors that work in this Ethereum supply chain, like the proposers, the relays, and the block builders, somehow change some of these flows and cooperate with this. And the user could also be a roll-up or a wallet or something, but that would pay basically a fee for this transaction inclusion. So here's basically how it will work, right? The user, and I should also mention, there's different approaches to pre-confirmation. There's one approach which leverages the validators, the proposer, to give a guarantee. And there's another approach which focuses on the builder. So builder is kind of PrimeF as a company focused on that. Proposer is like Chainbound, for example, and Commit Boost focus on that. So this is the proposer flow. So as a user, I make a transaction and I request a pre-confirmation and I pay some extra payment. I send this to the proposer. The proposer then basically tells the block builder, hey, when you create the block, you have to include this transaction. And then the builder creates a block that includes that transaction, sends it back to the proposer, and then it goes into the blockchain. So that's really how pre-confirmations work. Now, what are the upsides of this? Well, one potential is better user experience, right? Like you don't have to wait so long anymore to have a confirmation. But I think a lot of the interest around this is also around rollups and how it can power rollups, especially based rollups that use the Ethereum validator set as a sequencer. And So, you know, what are some of the potential upsides of this? I mean, potentially, right, if it improves the Ethereum user experience, it could help getting more usage of the network. It may also have some impact on MEV rewards, which is still complex to see what that would look like. But one of the big challenges is, how do you price a pre-confirmation? So as a proposer, someone says like, hey, include this transaction and I pay you X. Like, what is an appropriate amount for X? You know, because in the end, this is also something that can then constrain the builder in terms of how that block looks like, so it can potentially decrease the value of the block to the builder. So you have to somehow weigh these two things, and you know, that's a hard problem that I think we don't have great answers for. If someone's interested, we have some website which is very technical but kind of goes into this a little bit. So you can go check out preconf.chorus.one. We've been involved in this since the beginning. So you can see we were did one of the first pre-confirmation transactions on the testnet. And but it's still very early with pre-confirmations. I think it's going to take quite a while for this to roll out because it requires a lot of different parties. They have to figure out how this whole thing works. So I think realistically, it's probably like 2 years away from having, you know, real scale adoption of pre-confirmations in Ethereum. So next thing, restaking. So restaking, of course, is a very simple idea, right? Like, you're staking a token, and then the token is often slashable. But if you look at the history of Ethereum, I think in the entire history of Ethereum, the amount of ETH that was slashed is like $4 million. So it's a tiny, tiny, tiny amount compared to how much has been staked. So you can see that really, like, the thing that's at risk is actually very small. And mostly it's just that capital is like locked up and sort of doing not much. And so, of course, the idea of like, can I use that capital to do something else has been around for a long time. And it's a very promising idea. In Cosmos, there's been various efforts here. In Solana now, there's many, although these came later. But of course, the space where we've seen the most development here has been Ethereum. Especially with EigenLayer leading the charge here, but more recently also Symbiotic getting some good traction. But the idea is really that you stake the token, and now you use the stake token to secure some additional services, and you get some additional yield from that. So if you look at the market here, so currently you have around 5 million ETH, so that's, well, probably less than $14 billion now. But hopefully soon 14 billion or more again, but that's basically in restaking protocols right now. So if you compare this to the overall staking marketplace, you can actually see it's quite a lot, right? So in a relatively short time, we managed to get, you know, around a seventh of the staked ETH also being restaked. And if you see the distribution here, you can see that EigenLayer is very dominant, with something like 85% of all the ETH being restaked to EigenLayer. You have Symbiotic in number 2 with 10%, and then Kerak has 4%. Now, this is another thing that's interesting. So if you look at Lido, right, you have around 9.4 million ETH staked, EigenLayer 4.4 million. What's also worth noting here is that actually a lot of the stake is native stake, so it's not a liquid staked tokens. Now the reason for this is that is this one here, right? Because most of the ETH that is being staked through restaking protocol actually uses these LRTs. So it's basically like another liquid staking asset that's being issued. And these LRTs, they don't want to pay the extra fee to Lido, right? So they basically say, hey, we are going to stake it directly to basically save cost and increase revenues. So that's why you have, that's why out of the EigenLayer thing, most of it doesn't come through liquid staking asset, like staked ETH or something like that. But we can also see, I mean, EigenLayer has had a tremendous success in attracting a lot of stake to the platform. You can see here the kind of growth of EigenLayer. You know, it grew very quickly, but it has been going down a little bit for a while. And you can also see it had some negative impact on, for example, Lido's TVL, where some of Lido's TVL moved over to EigenLayer. Now, I think this is a very important thing to wrap your head around, is actually the economics of restaking. So the basic staking yield, let's say we put 3.5% there, you know, it varies of course, but like it's something like that. Now, if you do restake, then you can earn some additional yield. Now, where does this additional yield come from? I mean, one is the native token of the restaking protocols, like Eigen. That was pretty high in the past, but it has dropped, and today it's around 1% or even a little bit less. Then you have LRT incentives. Now, those also used to be pretty substantial, but they have basically stopped at this point. So they've used a lot of these incentives to bootstrap adoption, and now they kind of run out. So that only contributes a little bit to the APR. And then finally, we have the rewards coming from the AVSs. I wrote 0.2% there, but that's actually probably overestimating it. Like right now, they're close to 0. So now that means that the restaking APR has been going down and down. And I think that's going to actually pose quite a challenge for restaking protocols, and especially Eigenlayer probably. Because what you can see is there's actually a tremendous amount of leverage in restaking. So people restake the token, and then what a lot of them do is, so they put it into something like EtherFi or Renzo. They get their LRT tokens, or the EtherFi ETH, Easy ETH from Renzo, or Kelp ETH, and then they put this into Aave, they borrow ETH, and then they loop this. So you can see here the amount of leverage here. You can see that for all of these protocols, a majority of tokens, in the case of Kelp, it's almost 3/4, are actually deposited in Aave, and they are being used to basically leverage this up. Now, of course, the challenge here is that if the staking APR for restaking keeps going down, then you're probably going to see a lot of this stuff unwind. So I think what we can see from this is that it's really essential for restaking and for platforms like Eigenlayer and Symbiotic that we're going to have like real yield from the AVSs, because that's the only thing that's like sustainable and long term. And I think what we're probably going to see is that we're going to see a kind of unwinding of a lot of this leverage and a decrease in the TVL. And then I think we really need to see the ABS yields come up for this to kind of revert, and for like ETH wanting to probably stay in restaking protocols. So that's kind of like the restaking. Now, of course, restaking has a lot of nice properties, right? Because it means you can use those assets to secure layer 2s. You can secure other types of infrastructure like bridges, oracles, data availability networks like EigenDA, and it improves the capital efficiency, and of course for the stakers even today, right? It still provides additional yield. So that's restaking, and I think it's it's kind of a nice. It is something that's very promising thing for the future of Ethereum, where Ethereum can be used to really secure a lot of additional services and generate additional revenues. So I wanted to touch a last topic very briefly, which is around MEV and timing games. So this is one area where we were quite active in the past, but basically it has to do with the following, right? If a validator creates a block, then the later in the slot that block comes, the more valuable it becomes. The reason for that is that you have more transaction and they have more fees, and MEV, a lot of the MEV comes from the divergence of the prices on DEXs from the prices on like Binance or like, and so as that divergence goes up, the MEV goes up. So you basically have some kind of curve where the value of a block goes up as time goes on, and it's not a linear increase. It goes up kind of more steeply than that. So if you can delay when you create the block, you can generate more value and capture more value. So so this is one thing we were working on very early on. So we were the first ones to really systematically experiment with this, and we created a modified client called Adagio that basically changed the latency parameters and tried to measure how late can we propagate this block and to increase and to generate additional MEV revenues. So, you know, we generated quite a lot of additional MEV revenues with this for a while. But then what actually happened is that the relays, so ultrasound and others, they said, well, we should also include that, right? We should start holding back the block and do it a little bit later to increase the value of the block. So that has also meant that our particular, you know, Ethereum fork we were running has become kind of less useful because the whole network started adopting this approach to increase the value of Ethereum blocks. So now, of course, there are always going to be new things around latency optimization and generating more MEV returns. And so, you know, we are exploring some of those new things now. So, yeah, if someone's interested, there's some kind of academic paper we wrote on this topic in the past. So, yeah, that's all from my end. If you want to reach out, feel free to email me or check out Chorus.one or get in touch. And thanks so much.
Thank you, Brian Crane.
That's just a beta test for Boodle. Just dreamers, on-chain truth, no middle schemers, forking hard and shipping code till sunrise every day. DAOs are voting, vibes are flowing, buff-eyed corns are still a-growing. While the world is breaking down, we're regen in a new way. Some VC said this tech won't last, and a hurt bubble, watch it crash. But we don't need your central banks, 'cause regen fiddlers stack in stacks. For we pity let this city on sports and chains. We pity let this city with regen brains. We pity let this city on sports and chains. No rug pulls, just pure on chain. Whale pools floating, fees are burning. ZK proofs the chains keep turning. Every block we validate is trustless, clean and fair. Open source and gas optimized, cause permissionless and finalized. Fork marmots on the scene, you know we're gonna bid a little it there. Some TradFi bro just rolled his eyes. Where's the yield? Where's my supply? But we don't need your banker games. She's a Colorado Comet in code forged steel, wings snipping latency like scissors through gel, 9 centuries young. Armor clinking with layer 2 lullabies, scalability scripture. She winks at the moon while Lagron drools over slow motion doom. Grind, her shield's a disco wall, fracturing legs, grass, shooby-doo crack. Ooh, that lance a lightning fork, splitting bottlenecks backs. Alliance architect with a bluff the corn's grit, teaching stale protocols how to fucking commit. Decentralize this, she smirks mid-flight as her wings tickle nodes into doing things right. Da-da-da-da. Architect with a buffercorn's grit, teaching stale protocols how to fucking commit. Decentralize this, she smirks mid-flight as her wings tickle nodes into doing things right. Up to do with for do with for do with you ordered a moonwalk across gas feed graves. My mainnet's smoother than your mom's VPN saves. Daughter of the Rockies, high-speed high priestess, scales of justice ballast on a Memphis Express. Next bottleneck, I see mountain crush it. Click, clack, bosom, lace on firewall. Eyes spooked and truce from trash sheets. That's my device. Nullifier sniffing on my cokes too crisp. Mainnet gossips, tastier than breakfast chips. Story, hack, flurry. Mama's making news before the cold reload. Got receipts in my cheeks, encrypted and plumbed. Your private DMs, I'm the dumpster dive chump. Eyes everywhere, that's 3 bird phones. Quantaries whisper, king chomp and blockchain bones. Make it down to my voted fuck. Stealth crawl through your junk dead scene. Head it up to the entropy. Mace cracked vaults like who's got the keys? Nullifier's huffing, you're just a rat with his firewall splinter to confetti bits. I'm curating leaks at the after party, sipping TLS tears. Call me well connected, I call it. Coffee for drip and the lab coat on fire. Sticky note constellation stuck to the ceiling wire. Gas fees are confetti, they rock on PI. Get homemade in 7 for a time. Shaboom, dose, the efficiency pulse. The lag runs lagging in his latency sub. Professor Way's got the future on spin, book. Urgent notes dancing where the bottlenecks been. Professor Way's got the future on spin, book. Bugging tomorrow with yesterday's RAM stains. Velcro boots clicking through blockchain debris. drunk bumblebees. Optimize the boothins. They cackle and shout. Self-sustaining hubs flicker in the blackouts out. Professor Way's got the future on spin. Urging notes dancing where the bottlenecks been. Professor Way's got the future on spin. Plug in tomorrow with yesterday's ram stains. Chaos is not a compeller. Order's just a bug I forgot to unfurl. Mainnet shivers as their wild hair glows. Rumored AI? Nah, just 3 Red Bulls in a row. What you building? Prop? A singularity jukebox. How you stay charged? Espresso streak through my cortex. Who's your nemesis? Light runs dial up found. Age? Old as speak, young as each block mine down. Professor Way's got the future on spin. Urging notes dancing where the bottlenecks been. Professor Way's got the future on spin. Plug in tomorrow with yesterday's ram stains. Throwing me mad, running me mad's just a beta test. A bullet or oh, Pete Jobs tried to do oh, Pete Jobs tried to do oh, Pete Jobs tried to do oh, Pete Jobs tried to do. We're biddylers, not just dreamers. On-chain truth, no middle schemers. Forking hard and shipping code till sunrise every day. DAOs are voting, vibes are flowing. Buff corns are still a-growing. While the world is breaking down, we're regen in a new way. Some VC said this tech won't last. And the hurt bubble, watch it crash. But we don't need your central banks. 'Cause regen biddlers stack in stacks. For we biddy let this city on sports and chains. We biddy let this city with regen brains. We biddy let this city on sports and chains. No rug pulls, just pure on chain. Whale pools float in feet.